training a model, evaluating the model in Visual Studio using the ML.NET Model Builder. Okay, let's open Visual Studio, and first we're going to go to Visual Studio installer to make sure we have all the machine learning components installed. Just do modify ML.NET Model Builder. Let's definitely check that one. When that's installed, maybe just restart Visual Studio, maybe your computer, and then open it. Visual Studio. I already made an ML.NET project. If you haven't, just create a new console app. Okay, that's why I don't like Visual Studio. You have to fucking Google how to zoom and you can't find it after all. Okay, let's start. So I have my little project. I go to add, machine learning model. Just click add. Okay, now we can choose either forecasting, but that's time series based. We're not there yet. Let's do value prediction, which is the second one. Local. Gonna use the local CPU for now. Now we're going to use a file, CSV file. I'm going to use one from the Microsoft documentation, one of the official examples, which is the train dataset, which is gonna try to predict the fair amount for a taxi, if I'm not mistaken, based on its other features. Then I'm gonna go to advanced, well, first the column to predict, so the label, the Y value is gonna be the fair amount, and the rest is are going to be the features. But I'm going to simplify it for now, so fair amount is the label. Then I'm going to advanced options, and I'm going to, for now, to keep it simple, toggle off some other features. Let's see, rate code is what? Let's say we want to keep it very simple and just have the trip distance as the only feature for now, which there's likely going to be more important features that I toggled off now, but that's what it looks like. Oops. Yeah, fair amount and trip distance. So feature and label. That's going to ask for how long to train. I'm going to just put it to 100 now. Let me see. It's going to tell me, because the CSV file is so large, that it would be wise for me to train for 10 minutes. For the sake of this video, yeah, guess I'll have to do it. Well, you can just ignore it, actually. You can go to training options, and this is interesting, just to learn more about what's going to happen. So the optimizing metric is the R squared. The closer to 1, the better the quality. That's kind of our accuracy metric. So the opposite of the error rate, let's say. Then there's a few others. It's good to know. Then trainers. So this model builder is going to try different regression models. Some of them are linear ones, and other ones are decision trees. We'll see that later. And it says works well for this use case, works well for that use case. So if it's just linear, I think LightGBM is one of the better ones. If it's more complex, then you can use a decision tree. Tuners, hyperparameter tuners. Stop strategy. You could say max models to explore, time to train in seconds. I put 100. Gonna save that, but I forgot something. And the data, I can also add the validation data. So otherwise it's going to create a test set from the training data, so that we have our own test data. And it's kind of offered to split in 80-20. So it's going to have 80% of the training data it's going to use for training, and then it would keep 20% apart as test data or validation data to keep it away from the model. So the model can't learn that 20% of data, so that we can use that 20% of data to then evaluate the model on as a means of how well does the model perform on unseen data. That way we can verify that the model actually performs on, well, can perform in the real world on unseen data and not just on the data it has seen. So it didn't learn it by heart. Okay, start training. Continue, yes. Going to pause the video, but you can see it's trying different trainers and the R squared, so the closer to 1, the better. So we want a model with maybe 0.7, 0.8, 0.9 maybe, if possible, but we only have one feature to learn from. So okay, so it completed 100 seconds. Total number of models explored 70. Let's see, the top 5 models: fast tree regression, so decision tree, we've got an accuracy of 63%. That's not that great, but yeah, we did a very simple training on just on one feature to predict the fair rate. Then it's going to show how we can consume the model. It should have saved the model to the project, and so on. We can train again, maybe longer, to possibly have a better outcome, or we can just go to next step. We can even try our model. So now we do like a trip distance of 1.5. Let's try to predict the fair amount, which is $46, I assume. And you can play around with that. And then you can either copy the code or yeah, create a new project to consume the model. Anyway, I'm not gonna dive too deep into that because I'll switch to Visual Studio Code in a bit. On the side, and here you see, well, basically copy. Let's say we go to the program CS and we do this. Basically, we can now start making predictions on that trained model. But more importantly, you see this model, and it basically generated the code to train, to consume. So to load the model from the file, create a prediction engine, input output, we'll see that in a bit, and then actually predict the value. Then training, so we've got the path to the training data, how to read in the training data, the CSV file, so comma separated. Then we can train, load the data, so into the data view, which is a bit similar as in Python. You have pandas data frames. It's kind of a column-based representation of your data, which can be useful. Then you can easily drop columns or inspect columns or replace data cells in there, data values in there. Then to train the model, all the code is basically generated. So here, load from file, train the model, it's going to build a pipeline, and then the fit method, it's going to actually train the model. To build that pipeline, we can do some transformations on the data. We'll see that in a bit, like replacing missing values or renaming columns, dropping columns, and so on. And we then append our training algorithm with some optionally some specified options like the learning rate. Okay, then evaluation. This is something you can either visualize or calculate. The feature importance. We want to predict the house prices, let's say, based on the number of rooms, and we want to make sure that there's like a linear relation or correlation between the features and the label. So if there's a linear, like if there's more rooms, there's likely going to be a higher price. Anyhow, feature importance. So we kind of want to detect which features are actually contributing to a good prediction. So that could be the amount of bedrooms, the property size. Maybe not the name of the sister of the previous owner, for example. It's not going to be an important feature. Okay, and then we can even plot this, but that's all for that. Like, subscribe if this was useful, to follow along for next episodes. To become a member, I'm going to drop the notebooks on there, not all of the data, but the code. And check out my Gisco.com product website